Hello. So we previously completed our ionic bonds gizmo, and this is where we were balancing out our elements or stabilizing them by having metals donate their valence electron to the valence shell of nonmetals. So in this case, we have sodium and chlorine. And here we have stabilized this molecule. Notice we always click check. Congratulations, we stabilized the molecule or the elements to create this molecule where it's NaCl. So today we're going to show you how to quickly just um, get these formulas by writing out the charges and then balancing the charges or canceling the charges out, and then creating the formula. And then at the end, we'll go over the formula mass calculation using the periodic table. All right. So in this situation, if we look at sodium oxide, so I have sodium over here. I click on oxygen, and this is just using the gizmos. We won't be using this at all after this moment. So in this case, we needed a complete valence shell for sodium, so we donated one electron from sodium. It's oxygen. We checked for stability, and then we noticed that not all elements are stable, meaning that not all elements had a full valence shell. Sodium has 8 electrons and it's completely full, whereas oxygen only has 7. So what we needed to do is add another metal or another sodium and donate its valence electron to oxygen. We check it, and it's stable. And notice our new molecule. So we're going to go ahead and see what that looks like right here for sodium oxide. And we'll be getting the same formula, but in a different way. So anyways, here is a visual aid to use. We'll be using another one at this point. So let's go ahead and look at our document. And here's what we have. Now, just keep in mind that there is a backside to this paper. I got this periodic table with charges from this website here. And all it's saying is that since all of the group 1 elements have one valence electron, they end up having a charge of positive 1 because they donate 1 electron, and now it has 1 more proton. Group 2 elements, they donate 2 electrons, making it more positive. We don't care about these right now, they're too complicated. These items right here, they donate 3 electrons and they become positive 3. Noble gases don't donate anything because they are stable. And to become stable for these elements here, they all accept electrons. Everything in this column accepts 1, these accept 2, and these accept 3. There are anomalies, but we don't care about them right now. All right, let's get started. So for sodium oxide, let me zoom in. So for sodium oxide, all right, notice sodium is here and it has a positive 1. So I'm going to put Na plus. Oxide or oxygen, well, oxide meaning that it is an ion, specifically an anion, a nonmetal that has already accepted electrons. It has a charge of 2 minus. So I'm going to put O2 minus. All right. So in this situation, we need to have our charges cancel out. So we need to have, in this case, if we have -2, a charge of -2, we need a charge of +2 on this side. So to do that, we need another sodium ion. So now these two have a charge of 2 plus, and this one still has a charge of 2 minus. So now it's balanced out. The charges cancel each other out. And now we just write out our formula. We have Na and oxygen, but notice we used 2 sodium ions, so we write Na2. This is the same as what we did for the gizmos. Notice Na2, we have 2 sodiums, these purple items, and then oxygen. We only have 1. All right, let's try out another one down here. Let's try beryllium oxide. So beryllium oxide is Be. It is this item here. All right, remember this chart is in the back of this worksheet. So beryllium 2 plus. So I write Be 2 plus. I have oxide, or my anion of oxygen, and it is O2 minus. Whoops, I put a plus sign, that's a minus. And since the charges are 2 plus and 2 minus, they cancel each other out. Then in this case, it just becomes BeO, and we only use 1 and 1. All right, let's try this one. chromium oxide. Chromium is somewhere in this center area here, and it has a different type of oxidation, meaning that its charge varies for its stability, but right now it is in its chromium 3 form, so it is going to be a cation that has a charge of 3 plus. So let's try this out right here. Actually, I'm going to go to the back side. So chromium 3 plus, oh my bad, chromium oxide 3. So we have Cr, and actually I forgot what chromium is. It's been a while since I've seen that. Here it is, Cr. All right, so we're going to do Cr. Going back to the document, they said 3. So this 3 right here, what they were showing, to see it better, this 3 is just saying that it has a charge of 3 plus. So we're going to go ahead and write out 3 plus, and oxide is still O2 minus. So now let's try to balance this out. So since we have 3 positive on this side, we're going to add another oxygen to make it 4 minus. It is still not balanced. All right. These charges need to be equal but oppositely charged. So in this case, now we need another chromium 3 plus. Now this amounts to 6 plus, 3 plus 3, 6 plus, still not balanced. We need another oxygen. All right. So now we end up with a charge of 6 minus, 2 minus plus 2 minus plus another 2 minus plus another 2 minus equals 6 minus, negative 6, and our charges cancel each other out. So in this case, we used 2 chromium cations, and we used 3 oxide anions. So in this case, it'll be O3. All right. So this is our formula that we need. So it's Cr2O3. And now for the calculation, we'll go ahead and work with chromium 3 oxide. So let's see over here. For the formula mass, we're going to round to the nearest hundredth. So 51.996. Well, in this case, we'll just try it a different way. We'll just write it out. So it'll be 51.996 times 2, because we have 2 chromiums. And then we add the oxygen, but notice we have 3 oxygens, so it's 16 times 3. So 51.996 times 2. We get 103.99 plus 3 times 16. That's going to be 48. So let's just go ahead and add 48. We get 103.99 plus 48 is equal to 151.99. That is the formula mass for this molecule. Go ahead and try this out for all these other elements. In this situation, we'll try out BeO right now. Notice BeO, we have beryllium with 9.01. I'm going to go ahead and round to the hundredths. That's 2 numbers after the decimal. Plus oxygen, which is again 16. And that's actually 15.99, but I rounded up to the nearest hundredth, and this goes up to 16. So I go ahead and add this. 9.01 plus 16 is just equal to 25.01. Anyways, please go ahead and create your compounds, and then calculate all the formula masses for all of these ionic bonds.